This is the CCEA Maths paper. We're looking at M8 paper 1, and this is from 2021. So let's go ahead and look at the first question. Simplify each of the following: 4p cubed times 3p to the power of 4. The 4 times the 3, first of all, gives us a 12. The p cubed times the p to the power of 4, of course we add the powers there, so that gives us then p to the power of 7. Q squared all cubed, our rule there for indices is we multiply those two indices, so that gives us q to the power of 6 divided by q to the power of 8. We now subtract these two indices, so it's 6 take away 8, so we get q to the power of minus 2, or if you want, 1 over q squared. Either of those answers would be fine. Find the nth term of the sequence. I like to number them first of all. 1, 2, 3, and 4. Then I find the gap. Be careful here, the gap isn't 3. The gap is minus 3. That tells me the term that I multiply my n by in my nth term, so it's minus 3n. I substitute the number 1 into this here. Minus 3 times 1 gives me minus 3, but I want 7, so I need then to add 10 to it. So my nth term is minus 3n plus 10. Tony tests a 6-sided dice which he thinks is biased towards even numbers. He carries out an experiment by rolling the dice. He records the results as even or odd. What is the relative frequency of an even number? So it's 1, 2, 3, 4, 5, 6, 7. And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 trials. Okay. How could Tony improve the experiment? Of course, he would just kind of do more trials. So, increase number of trials. The way this question is, it says he thinks it's biased towards even numbers. It's very hard to tell with just 12 rolls of the dice, so if he does a couple of hundred, then you get a better idea. Make y the subject of the formula. We effectively want to get rid of this minus 12 and the 3, so we would add 12 to both sides. That would give me 3y equals 4x plus 12, and then divide by 3, and I would get y equals 4x plus 12 over 3. So y equals 4x plus 12 all over 3. Another acceptable answer there would be 4x over 3 plus 4, because the 12 divides by the 3, but either of those are fine. On then to question 5. A rectangle has a length 3x and a width of x plus 5. The length is greater than the width. Write this information as an inequality. They're telling us that the 3x is greater than the x plus 5, so we just write that down. 3x is greater than x plus 5. Solve the inequality. So I would take away x from both sides. That would give me 2x is greater than 5, and then divide both sides by 2. X is greater than 5 over 2. So my answer then is x is greater than 5 over 2, or if I want 2.5. Show your answer on the number line below. So it's a 2.5, and it has to be greater than, so we don't colour in our circle here. So a 2.5, and then I have my arrow going that way. Question 6. ABC is a right angled triangle. Work out the length of AB, giving your answer as a surd. I would label my sides A, B and C, not to be confused with the capital A, B and C. So C then is my longest side. That would be A, and then that would be B. So A squared plus B squared equals C squared is Pythagoras theorem. My A squared, so it's the square root of 19. Remember, I have no calculator here, so I need to think about this one. Plus B squared, and that equals then 121, because 11 squared is 121. So that's the thing about this. 19 square root then squared. So if we do the square root of 19 and then square it, we just end up with 19. So that actually gives us 19 plus b squared equals 121. That means b squared gives me 102. I've taken away 19 from both sides, and so b then in this case is then just going to be the square root of 102, and we just leave our answer like that. It says give your answer as a surd, and so that's the answer that they require. PQR is a right angled triangle, and QS is the perpendicular line going from Q to PR. Prove that the triangles PQR and QSR are similar. Well, we need to show, the way you show two triangles are similar is either if the sides are in ratio, so we don't have any sides here, or that the angles then are the same. So hopefully we can see that PSQ is a right angle. So that means that QSR is obviously then going to be a right angle as well. QSR equals PQR. So it's equals 90 degrees. So in the big triangle and in the wee triangle, we have a 90 degrees. So one of the angles then is the same. In the big triangle, we have angle PRQ. Again, I hope you can see it, PRQ. And in the small triangle, we have SRQ. And they're both the same, because they're both in the same spot. That means then if two of the angles are the same, therefore third angle is also equal. And if all three angles are the same, then similar. Triangles have to be similar to each other. Question 8. Special menu. Let's read the question first. A restaurant has the above special menu available. How many different ways are there of choosing two courses, starter and main, or main and dessert? So let's just count them out and see what we get. So starter and main, first of all. You could have soup of the day with fish, chicken, pork, steak, or spaghetti. That's 5. You could have Caesar salad with fish, chicken, pork, ribeye, spaghetti. You could have brie. Do you see what's going on here? So there's 5 of this, 5 of this, 5 of this, 5 of this. So that's 5 times 4, which is 20. That's going to be for starters and mains. For mains and desserts, you could have fish of the day with cheesecake, apple pie, ice cream. Or you could have chicken Kiev with cheesecake, apple pie, ice cream. Again, I hope you see the pattern. There's 3 times 5. And that gives me 15. So my total then is 20 plus 15. And that gives us then 35. Question 9. Rearrange the formula to make R the subject. So this is a slightly messy one here, but we should be okay. You've maybe even seen this one before. So I would times both sides by 3. That would give me 3v is 4 pi r cubed. We want to try and get the r on its own, so we want to get rid of the 4 pi, so we're going to divide then by 4 pi. That's going to be 3v all over 4 pi, and that equals r cubed. If we have r cubed, how do we get r? We got to take the cube root. So r is going to equal to then the cube root of 3v all over 4 pi. Question 10. The height of a balloon h varies directly as the square root of its surface area. So the height of the balloon h means is proportional to the square root of its surface area. That means k times the square root of a. This information, when the balloon surface area is 81, its height is 12, is going to help us work out the k. So we know the height is 12, so we know 12 equals k upon the square root of 81. So 12 is 9k. And then 12 over 9 equals k. So k is 4 over 3. So we now have our formula, so we can work out this bit here. We know that h equals 4 over 3 root a. H equals 4 over 3 times the square root of 144. H then is 4 over 3 times by 12. So 12 divided by 3 gives me 4 times 4. My answer then would be 16. Number 11. Change 0.01717 into a fraction. Our wee trick for this, there's two numbers repeating, so we would times it then by 100. So I'm going to let x and then 100x. So I'm timesing this by 100. It's going to give me 1.7171717. And of course both those go on forever. If I do this, take away this, 100x take away x gives me 99x. And if I take them away here, I get 1.7, and then this cancels with this, and they all cancel each other out. That means x is 1.7 all over 99. And if I times both by 10, you can't do a decimal in with a fraction. We would have 17 over 990. Question 12. P is a point on a circle x squared plus y squared equals 169. P also lies on the line y equals 12. Show that the radius to P has gradient plus or minus 12 over 5. 169, the square root of that is 13, so the size of my circle then the radius must be 13. You don't need to do a DB diagram, but I just think it helps me picture what's going on. So here's my circle here. And then the line y equals 12. The line y equals 12 is a horizontal line going through then the point 12. And these then are the two possible points P that we could have. So let's take a look then at what I show that the radius to P has gradient 12 over 5. So the point P, we know the y coordinate of it is 12. So if we go x squared plus 12 squared is 169. X squared plus 144 is 169. X squared then is 25. Taking the square root, then x must be plus or minus 5. The gradient then, so this here is the point 512. This here then is the point minus 512. And so we're looking for the gradient of this line here, or we're looking for the gradient then of this line here. So if we set up our wee triangle here, that's 5 across, and that's 12, across 5, up 12, so that means the gradient equals 12 over 5 in this case, or in the other case, minus 12 over 5. Okay. Part B, hence find the two possible equations for the tangent at P. So let's go back to our wee diagram here. We're looking for this line here, or we're looking for this line here. This is of course a right angle. So if the gradient of this here is 5 over 12, the gradient of this is going to be the negative reciprocal, so we would flip that upside down to get 5 over 12 and change it then into a minus. So my two possible tangents, so possible gradients of tangents are minus 5 over 12 or 5 over 12. I hope you see where I got that from. And then we sub this into y equals mx plus c. So y equals minus 5 over 12 x plus c, or y equals 5 over 12 x plus c. We also need a point on the line, and we know on this one it's the point minus 5, 12 is on the line. That means 12 equals minus 5 over 12 times x. So it's minus 5 over 12 times 5. That gives me 25 over 12 plus c. And that means c is 12 take away 25 over 12. And that gives me then 100. No, it doesn't. It gives me 169 over 12. The right point there, yeah, the minus 5, that's okay. So my equation then is y is minus 5 over 12x plus 169 over 12. Very similarly then for this one, it's going to be the point 5, 12. So of course we'll have 12 equals 25 over 12 plus c, and of course it's just the same thing. I'm going to get c is 169 over 12, so y equals 5 over 12x plus 169 over 12. On the grid is drawn the graph of y equals x squared minus 3x plus 1. By drawing appropriate lines, use this graph to find the gradient of the curve at the point 2 minus 1. So the point 2 minus 1 across 2 down 1 here, we just need to try and find the gradient. So we're just going to stick in a line here and see if we can get some sort of gradient. It's just trying to work out your best gradient here. I think they're kind of giving you a bit of a clue as to what it should look like. But if I have that line on there, and I'm trying to work out the gradient, I've made life nice and straightforward for myself there, because we can have this and this. That's 3. That's 3. So gradient in this case, of course, is gradient. And if you want to do it as rise over run, and that's 3 over 3. And so the answer then to my gradient would be 1. Part B then, the equation of a line is obviously x squared minus 3x plus 1, and I need to make it then a minus 3. So I would have that. So if I draw the line y equals 4 on the line and read off the information, then that should give me what I need. So back to this then. Y equals 4. So reading off that, that looks to me that's the point 3.8, and then that's going to be minus 0.8. Minus 0.8. Again, as I say, x squared minus 3x plus 1 is my curve, and I need to make it into this. So that's equals 0. I would take away, you see, changing this one then into this, I would add x to both sides. So it would give me x squared minus 3x minus 1 equals x. Get rid of this 0. And then I need to then kind of add 2 to both sides. So that would then be x plus 2. So I want to draw the line y equals x plus 2. So the line y equals x plus 2 crosses at 2, and has a gradient then of 1, so it'll be across 1, up 1, across 1, up 1, and so on and so forth. Excuse me while I turn this around here, just to get a reasonably accurate line. So that's the line y equals x plus 2, and where do they cross? It crosses here, and it crosses here. So that looks to me to be then 4.2, reading off there, and then I guess just minus 0.2 if you wanted, minus 0.25, but I'm just going to go for minus 0.2. My two lines then are, sorry, my 2 points were 4.2 and minus 0.2. Next question is to question 14, and they have to work this out. So, well, with a couple of different ways that we can try and suss this out. We could do is try and find the same common denominator. So we want to rationalize the denominator of this one. So we would multiply top and bottom by root 3. So that would give me 4 root 3 over 3 plus root 3 root 27 minus 8 all over 6. Again, I'm going to times top and bottom of this one by 2. I'm also going to multiply out this bracket, see if we can start to tidy things up. So it's going to be 8 root 3 over 6. Root 3 times root 27 gives root 81. So that actually, yeah, let's just write it in. Root 81 minus 8 root 3. That's all over 6. We now have the same denominator, so we can join everything together. So we have 8 root 3 plus root 81 is 9. Take away 8 root 3. And that's all over 6. That is going to cancel with that. So I just have 9 over 6. And that cancels down then to 1. Question 15, we have to simplify each of these. So I'm going to start with the bottom because it's a bit easier. Anything to the power of 0 is 1. 32 to the power of 0.2, that's the same as 32 to the power of a fifth. And they've picked that number on purpose because 32 does have a fifth root. 2 to the power of 5 gives 32. So that just gives that. 25 to the power of a half gives me 5. But it's minus a half. So that then would be a fifth. So we have a fifth over 3. A fifth divided by 3 then gives a 15th. In each case, decide if x, y, or z is rational or irrational, giving a reason for your answer. X is the radius of a circle of circumference 12 pi. So C is 2 pi r. 12 pi equals 2 pi and x. I'd see what I've done there, change my r for my x. If I divide both sides in by 2 pi, I get x equal to 6, and that is rational because it equals 6, and 6 is a rational number. Y is the radius of a circle, area 9 pi squared. So area is pi r squared. 9 pi squared is equal to pi times y squared. I divide both sides by pi, and I get y squared equals 9 pi. So that means y is equal to 3 the square root of pi. And if you have pi involved in your answer, it's going to be irrational. The root pi is irrational. Z is the radius of a circle of area 8 So pi r squared equals a. Pi z squared equals 8 pi. The pi's divide. So I have z squared equals 8, but if you take the square root of 8, it's going to be irrational. So z is the square root of 8. So it's still then irrational, because root 8